ladies, I am going to give you a quick review of working with positive and negative numbers. You should have seen this last year in your pre-algebra, or those of you who are did part of an Algebra 1 class, you've seen this before, so hopefully this is just going to be a reminder to you of how to work with positive and negative numbers. So first, I just want to remind you of what positive and negative numbers look like on a number line. We take 0 as, let's put it sort of in the center of the drawing. It doesn't have to be the center. And we put some numbers over to the right-hand side. I'm going to put the integers on here. 1, 2, 3, 4. I can get it out to about 5. Then there are matching negative values on the other side of the number line. You probably spent a lot of time working with number lines when you were first learning about negative numbers. Okay? So there's just a mirror image of it. Any number that's on the right-hand side is a positive number, has a mirror image number on the left-hand side, a negative number. So, for example, if we wanted to look at the fraction 1/2, the fraction 1/2 would be right there in the middle between the 0 and the 1, and the fraction negative 1/2 would be mirrored on the other side in between the 0 and the negative 1. It would be right there. If you wanted to look at the number 4.8, it would be over here between the 4 and the 5, closer to the 5, just to estimate it over there, kind of close to the 5, 4.8. And on the other end, between the negative 4 and the negative 5, closer to the negative 5 would be negative 4.8. So, like I said, hopefully you received a good bit of work with these negative, these number lines with negative numbers, but anytime you need to draw one to help you figure something out, that's going to be okay. Now, it seems to me that usually people work with horizontal number lines. I just want to show you what a vertical number line might look like. A nice vertical line, and we put the 0 here. When we draw horizontal number lines, we tend to put the numbers below it. And when we draw vertical number lines, we put the numbers to the left of the number line. That's just the most common place. Up will be positive, and down will be mirror image, will be negative. You may notice that I have not put arrows on the end of my number line. This is something that gets done lots and lots in middle school and Algebra 1 and Algebra 2. By the time you get into upper level math, we kind of stop drawing them. We just know they're there. You can put them there. They do kind of make me happy, but if you forget them, I'm not going to get very upset with you. If I wanted to put, say, a decimal, 1.5 on here, 1.5 would be right there, halfway between 1 and 2. And if I wanted to look at negative 1.5, it would be halfway between negative 1 and negative 2. So being able to find values on a number line is going to be kind of important for some things that are going to happen later on. That's just getting you sort of set up for the positive and negative numbers. We are going to go over now the rules for arithmetic with positive and negative numbers. And I'm only going to use integers for right now. No fractions, no decimals. That makes life a little bit easier while we remember what the rules are. There are different ways for you to write these rules down, and I always love to hear different ways that teachers have for helping you remember this. I'm just going to write them down in the way that I was taught them. And you can take them down, and then you can tell me in our next class if you have some other way of remembering it. All right, when we are adding positive and negative numbers, if you are adding a positive plus a positive, so just using a shortcut, or if you add a negative, nope, that's wrong, sorry. If you add a positive plus a positive, then you're actually going to take those two numbers and you're really going to add them, and the answer is going to end up being positive. If you take a negative plus a negative, you're going to take those two numbers, and again, you're going to think about adding them, but the answer is going to be negative. All right? So just to give you an example over here beside, I'm going to use 3 and 4, nice easy numbers. If I say 3 plus 4, nobody has any problem. The answer is 7. If I say negative 3 plus negative 4, that answer also is 7, except instead of positive 7, it's going to be negative 7. So you add the 3 and the 4, and the answer will be negative. Some people like to remember that if you're adding the same sign, you actually add them and you keep the sign, okay? The second one, or the third one, is you have to do a positive plus a negative, or a negative plus a positive. It doesn't matter which one comes first. One positive number and one negative number in any order. Your brain needs to not actually think of adding them, it needs to actually think of subtracting them, okay? And when you subtract them, you take the sign of the larger number. Use or take the sign of the larger, I'm going to put that in quotes, of the larger number. You know, now actually all positive numbers are bigger than negative numbers. But by larger number, I mean, which one do you have more of? Do you have more positives or do you have more negatives? And I'll show you two examples for this. Again, I'm going to use 3 and 4. If I take a positive 3 and add a negative 4, then my brain needs to think 4 minus 3. That's what you think. This little bubble is me writing down what you're supposed to think. You're supposed to think 4 minus 3. So the answer is going to be 1, but there are more negatives than positives. I have 4 negatives and I've only got 3 positives. And since I have more negatives than positives, my answer is going to be -1, the sign of the larger, the one that has more negatives. I'm not going to spend a lot of time on modeling this, but I know I have seen some teachers have taught this very introductory stuff by doing something like this. I have 3 pluses, and I have 4 minuses, and 1 plus and 1 minus cancels, and 1 plus and 1 minus cancels, and 1 plus and 1 minus cancels, and you're left with 1 negative. Therefore, -1. That's the way to think about it. Okay? All right, now we'll do another one. What if I had a -3 and a positive 4? Again, you're going to think, that's what this little bubble, this is like your brain, that's what that's supposed to be. You're going to think 4 minus 3. So again, you're going to think, well, the answer is 1. Which one do you have more of? Do you have more positives or do you have more negatives? You have more positives this time than you have negatives. And since you have more positives, you're going to leave the answer as 1. When you first learned this, you probably actually wrote the answer +1, but we don't get rid of that. We don't want to keep doing that. We just want to put a 1 there. That is understood to be a +1. Okay? Let's do a couple of more quick examples on this. We are going to do numbers bigger than 3 and 4, but it doesn't matter what the numbers are. If you have -21 plus 5, then your brain is going to think 21 minus 5, vertically, horizontally, whichever way you like it. And 21 minus 5 is 16. Okay? But which one is more? Which do you have more of? More negatives or more positives? And you have more negatives, and so you need to make this answer -16. Okay? I don't have to see any work for these. I need you to get the right answer, and I need you to be able to do it without picking up your calculator. We're going to do it both, with and without, but we need to be able to do it without our calculator going now. If the numbers are kind of weird or hard, maybe 2 plus -17, and you can't do it in your head, you need to, maybe you need to write down 82 minus 17 and write it on your paper. And don't forget that I expect you to remember some of your basic math, like carrying and borrowing, okay? And I do expect you to be able to get through that arithmetic without your calculator. I'm going to give you a lot of them, just enough to kind of keep your hand in it. So we're going to get the answer 65. And then you want to think again, which do I have more of? More positives or more negatives? Oops, not MOS, MOR. I have more positives. So this answer is +65. Okay? That's adding. All right? Subtracting. All right? Subtracting is very similar to adding, but it has an initial step. This is the first step. The first step is change the minus. I'm going to rewrite this so that it fits on the board a little bit better. I'm not going to change the words. The first step, change the minus do that, that's M-I-N-U-S. Change the minus to plus. When you do that, at the same time, and you have to do both of them, change the sign of the second number. Now, once you do this, you no longer have a subtraction problem. So your second step is to add. Just use the rules for addition. Okay? Let me give you an example. 7 minus 10. Following my rules, say change this problem to 7 plus, and instead of having a 10, change it to a negative 10. Now you have the rules for addition, which tell you to subtract 10 minus 7. So the answer is going to be 3. I have more negatives than positives, so the answer is actually going to be negative, getting the sign on it. Okay? Sometimes problems have lots of negatives or minuses in them. When there's only one, sometimes we can get there without showing any work. That's fine. But when there are multiple minuses, multiple negatives, or a minus and a negative, you probably want to show a little bit of work, at least until you get warmed back up after your summer. So I'm going to leave the first number alone. I'm going to change the minus to a plus, and instead of having a 5, I'm going to make it a negative 5. And now I use the rules for addition. They're both negative, so I add them. 3 plus 5 is 8. They are both negative, therefore my answer is going to be negative, and I get the answer negative 8. Okay? I'm going to do one more that's got 3 negatives in it. The more negatives, the more likely you are to make a mistake. When you get lots of negatives, just slow down. Okay? Slow down. All right. It's a subtraction problem. You don't change the first number, you leave it alone. You change the minus to a plus, and this number right here, this number was negative 4, and so it's going to become positive 4. Some middle school teachers talk about change to try to help that stick in your head. You may remember that. Okay? Now it's an addition problem. If it's addition, then we subtract. Our brain thinks 4 minus 1, which is 3. I have more positives than negatives, so the answer is going to be positive 3. So subtraction's not harder than addition. You just have to do one step first, and then it's just an addition problem. You don't need to actually show work. If the problem's easy. Now the definition of what's easy is different for different people. But when I say easy, I would mean something sort of old, and if you've done this for a long time, no one needs to show work. What's 8 minus 2? 8 minus 2 is 6. It's still 6. You don't have to start showing extra work for this simple problem. And some people even find with the backwards of that, the reverse of that, 2 minus 8, I don't really need to show work for that. 8 minus 2 is 6. 2 minus 8 is negative 6. But when you get to one that's got lots of negatives in it, I can guarantee to you that you are more likely to make a mistake if you don't show some work. So this is another one where we would leave the first number alone, change the minus to plus, and change the negative 2 into a positive 2. So instead of minus negative 2, we end up with plus positive 2. Okay, next we're going to go to our addition rules. We have a negative plus a positive. We need to subtract. What's 8 minus 2 is 6. I have more negatives than positives, so my answer is negative 6. Okay, so show work when needed, but there's not a very high tolerance for wrong answers on these. Okay? All right, let's switch over to multiplying. All right, again, I'm going to write the rules up. They're easy. If you have a positive times a positive, or a negative times a negative, in both cases, the answer is positive. People can get this mixed up. Going back and look at our addition rules, we had negative plus negative, which equals a negative. And if you're not careful about the way you think about this, you will get these mixed up. Try really hard not to use the word and when you're thinking about these. When you think of this rule here, when you're thinking this rule, don't say negative and negative, say negative plus negative. Negative plus negative is negative. And when you're thinking of this rule, don't say and, say times. Negative times negative is positive. All right, that's one that people get mixed up the most often. All right, and then the second half of that is if you have a positive times a negative, or a negative times a positive, then that answer is going to be negative. Now, I'm not going to go into the reasons for this. You should have received instruction on that last year, and if you want some help with it, I'll be glad to help you with it, but I'll need you to come after school for that. So, example, I'm going to use 3 times 6. This is an easy one. What's 3 times 6? 18. Next, what if I make them both negative? What's negative 3 times negative 6? The answer is still 18. Third, what if I make the first one negative and the second one positive? Well, the answer is still, well, I just changed the problem. If I take the first one negative and the second one positive, the answer is still 18, but now it's going to be a negative 18. And the last one, what if I leave the first one positive and make the last one negative? All right, the last one negative, then this answer is going to be negative 18. There's nothing to this, but you have to remember the rules. If you get the rules backwards, you're going to get lots of answers wrong, and it can be very, very frustrating. The good news is that the rules for dividing are the same as the rules for multiplying. So if you have a positive divided by a positive, or a negative divided by a negative, if they have the same sign, then the answer is going to be positive. If you have a positive divided by a negative, or a negative divided by a positive, the answer is going to be negative. So the rules are the same, so at least you don't have quite so many to do. The adding rules and subtracting goes together. Do one step and then you do adding, and the dividing has the exact same rules as the multiplying. So one quick set of examples, and again, I'll do one that I think most of you should know. 48 divided by 6 is one that we should know. 48 divided by 6 is 8. If I make both of those numbers negative, negative 48 divided by negative 6, then the answer is still 8. If I make one of them positive, say the first one, and leave the second one, make one of them negative, and leave the second one positive, then the answer will be a negative 8. And if you leave the first one positive and make the second one negative, 48 divided by negative 6, the answer will also be negative 8. Okay, so I've run through the rules. Tomorrow in class, or what's today? Wednesday, Friday in class, we'll spend a little bit of time on this, and this will be a part of your homework over the weekend.